let me show you something that's quite strange. See if you can spot the mistake. Watch it all the way through and then see if you can spot the mistake. Let's say you're trying to find out the limit of this as x tends to 0. So you would use L'Hopital's rule. So you would then differentiate this. That would then give you this. You would then differentiate this. That would then give you this. And then you would apply L'Hopital's rule again. Differentiate this. That would then give you this. Differentiate this. That would then give you this. Now, when you're here, as x tends to 0, this thing here will be 0, and this thing here will be 2. So according to this method, you are heading towards 0, because 0 over 2 is 0. So according to this, you're heading towards 0. So the limit here is 0. Now let's use linear approximation. Remember, with linear approximation, our sign of x looks like this. Near x equals 0, near x equals 0, we can approximate it to the y equals x line. So this here is sine of x, and this straight line here is x. So near x equals 0, we can approximate sine of x. Sine of x is approximately x. So when you're trying to find the limit as x tends to 0, if you're trying to evaluate the limit as x tends to 0, this will automatically imply that you are near x equals 0. Because as x tends to 0, so as x tends to 0, 10 to the power of minus 999 here. This is very, very, very close to x equals 0. So the minute you're trying to find the limit as x tends to 0, this thing here will automatically imply that you are near x equals 0. Well, if you're near x equals to 0, then any sign of x, you can replace it with x. So because we are evaluating it near x equals 0, we can just say this is the same. It's approximately this x here, because sine x is approximately x near x equals 0. Well, this thing here is near x equals 0. So we can say that this thing here, we can replace sine of x with x. So this stays the same. So now simplify this. This then becomes this. Well, if you look at 1 over x, the graph 1 over x, it looks like this. So here, well, let's just look at it. Let's just approach it from the right hand side. So approaching it from the right hand side, you are heading towards infinity. So this thing here is heading towards infinity. So when you're just looking at it from the right hand side, it heads towards infinity. But then according to this, the limit is 0. That means in both directions it should head towards 0. But then down here, this method here is saying if you evaluate it from the right hand side, it goes to infinity. So the two methods should lead to the same answer, but yet one leads to if you evaluate from the right hand side, one leads to infinity, the other one leads to 0. So the two methods should be the same, but yet they're giving us two different answers. So your job here is to try and spot the mistake. Okay, so press pause and think about it. Okay, so the mistake here is you should always check, because here you would check that it's well, if you plug 0 into here, you're going to get 0 over 0. Then and only then can you apply L'Hopital's rule, or infinity over infinity. But here we've got 0 over 0, so you can apply L'Hopital's rule. So differentiate this, that will then give you this. Differentiate this, that will then give you this. Now you should then check it again. So put 0 into here. This is 1. Put 0 into here. This is 0. So this is 1 over 0. You can't apply L'Hopital's rule. So in order for you to apply L'Hopital's rule, you have to have 0 over 0 or infinity over infinity. Then you can apply. Here you cannot apply L'Hopital's rule because you've got 1 over 0 here. So you have to come to a stop here and use some other method. You can't apply L'Hopital's rule again here. So the mistake is that you should check that this is 0 over 0. In this case it's 1 over 0. So you can't apply L'Hopital's rule. So the mistake lies in this step here. Okay. Okay, you can't apply L'Hopital's rule here. Okay, but this method here is correct. Okay.